All right, so we are on surface areas of pyramids now, 12.2, if you would like to follow in your books. All right, so your objectives: to find the surface areas of pyramids and nothing else. All right, some vocabulary. A pyramid is a polyhedra that has only one base. The base may be any type of polygon, so it doesn't have to be a square or a triangle or anything. It can be any type of polygon, but the lateral faces are always triangles and meet at a single point called the vertex. A regular pyramid is a pyramid that has a regular polygon as a base and congruent triangles for its lateral faces. So just remember that. If it says it's a regular pyramid, that means that whatever the polygon is at the bottom is a regular polygon, meaning each of its sides are equal. All right, so let's start with parts of a pyramid. All right, so I'll save this note for later. Altitude, that's the height of the pyramid, okay, formed by drawing a line from the vertex to a point perpendicular to the base. Slant height is a distance from the edge of the base to the vertex. So here's the edge of the base, here's the vertex, that's slant height, okay? So we'll move that out of there so we can move on to lateral edge, and that would be the edge joining the lateral faces. So both, as you see now, both the lateral edge and slant height determine a right triangle. So notice how this is a right triangle right here. And then if I step it back a little bit, that's a right triangle. So both of those determine a right triangle, so that'll help you. All right, so let's take a look at an example. So using the diagram below, we need to find ME, which is a slant height, to the nearest tenth. And we also need to find MC, which is a lateral edge, to the nearest tenth. And we are given that MO is 8, CD is 48, and BC is 12. Now I know this diagram does not look anything remotely close to that those proportions, but that was intentional. I wanted to prove a point that you cannot go by the diagram. All right, there's certain things you can assume from it, and there's a bunch of things you can't. So let's start with A. We know that MO is 8. We know that CD, which is this whole thing here, is 48. And we know that BC is 12. Probably not going to worry about BC for this one. Okay. What we are going to do is use the Pythagorean theorem to find ME. So actually, yes, we are going to use BC because OE is half of that, which means that OE is 6. So what we're not going to use is this right here. So we're trying to find this right triangle here. Okay? Triangle MOE, or as I like to call it, AMO. All right, so 8 squared plus 6 squared equals ME squared, which means that ME is 10, because we went through this problem before. You should know this by now. 64 plus 36 equals 100. Square root of 100 is 10. So ME is 10. That's our slant height. Now we need to find the lateral edge to the nearest tenth. So that's MC. Okay, so that right there. Again, MO is 8. Okay. CD is 48. And we know that ME is 10. Okay, what we're not going to use this time is this 8. Because if you notice, now that I know 10, okay, I have another right triangle here. And if you were to pull just that part out, we have 10 and 48 there. Okay, so we follow the same steps as before. So we need to find missing steps, missing side of triangle MEC, now that we know ME. So, and CE is half of CD. So, my bad there. It's a nice weekend. My head's not in the game. There we go, 24, but I caught my mistake. So, we have a 10, 24 for our sides. We use the Pythagorean theorem. 10 squared plus 24 squared equals MC squared. So, MC equals 26. So, our lateral edge is 26. All right, next example. So, given the diagram, find the lateral area and the total surface area. So, first lateral area, that's going to be all 4 of the triangles that make up the sides that come together at this point here. Okay, because remember, lateral area, we don't include the base, which is this here. So everything except for that. So let's start with the lateral area. Okay, we're going to use the Pythagorean theorem to find the slant height. Because what do we know? That's the slant height. If this is 12, then this is 6. Okay, so 6 squared plus x squared equals 10 squared, which means that the slant height is 8. Yeah, I know. You guys should know that one by heart by now. That Pythagorean triple. So the slant height is 8. So each triangle has an area of half of the base, which is 12, times the height, which is 8. And we have 4 triangles. So the area of each triangle is 48, and there's 4 lateral faces. So our lateral area is 192. That answers the first part. Next, we need to find the total surface area. Well, this is a piece of cake once we find the lateral area. We already know that, so all we have to do is find the area of the base. It's a regular pyramid, which means that the base is a square. Pardon my typo. Is a square. And we know that each side is 12. So, s squared, the side squared gives us the area of a square. So 12 squared equals 144. So 192 plus 144 equals 336. All right. Simple, right? So next we have surface areas of circular solids. Fun stuff. But that's not till next week. So enjoy your week. Hopefully you get these done over the weekend and get to enjoy the beautiful weather we're going to have in the beginning of this week. All right. Have a good one, guys. Only a few more sections left. 4 to be exact.